Most rockets attempt one risky thing per flight. Starship Flight 12 stacked a dozen of them onto a single mission and pulled nearly all of it off in front of a stunned industry. The launch and max Q. The stack came off the pad fast enough that the people standing outside to watch said the ground shook and the noise was overwhelming. All 33 Raptor 3 engines on the version 3 booster ignited and held, pushing the vehicle out over the Gulf within seconds. Telemetry stayed clean through the first 30 seconds, avionics and power reading exactly where they should. Then came the moment every rocket has to survive. Maximum dynamic pressure, the point where aerodynamic force on the vehicle peaks and the airframe takes its hardest beating. The stack pushed through max Q a little over a minute into flight without flinching. One engine did drop offline on the way up, leaving 32 firing, but the booster kept climbing on a stable trajectory. That margin, losing an engine and barely noticing, is the whole point of building a vehicle with that many of them. Hot staging and the new ignition sequence. Here's where the flight got interesting. Instead of fully separating the two stages before lighting the upper one, SpaceX runs what it calls hot staging, igniting the ship's engines while it's still physically clamped to the booster. The booster cut down to 5 engines for what the team calls MECO. Most engines cut off, and the clamps holding the two vehicles together retracted up inside a protective hot stage ring. Then version 3 did something different. Rather than firing all 6 ship engines at once, the 3 vacuum-optimized RVAC engines lit first. A single center engine followed almost immediately, giving the booster a deliberate kick to push it in a known, controlled direction away from the ship. The last 2 engines came online right after. It's a choreographed sequence, milliseconds apart, designed to protect both vehicles during the most violent transition of the entire flight. And it worked. The booster comes down. Not every part of this flight was meant to be perfect, and the booster proved it. There was no tower catch planned this time. The Super Heavy was always headed for a controlled splashdown in the Gulf, rather than a return to the launch site. On the way there, the boostback burn ended early, with fewer engines lighting than the team expected to see. But that's not the failure it sounds like. The booster's job for this mission was essentially done at separation, and watching it descend and hit the water gave engineers exactly the kind of real-world data they're chasing. Clear skies, cleared sea space, no surprises. The cameras tracked it all the way down as it came in hot and made it splash somewhere out in the Gulf. A return to launch site catch is the eventual goal, but you don't risk the whole test card to chase it on a flight this experimental. 5 engines to orbit. Up on the ship, that earlier engine loss became the real story of the ascent. Running with 5 of its 6 engines instead of a full set, Starship simply kept going. Engine out capability isn't a marketing line. It's the design philosophy that lets a vehicle lose a power plant and still finish the burn. And Flight 12 demonstrated it under live conditions. The team had planned roughly 8 minutes and 11 seconds of ship engine burn, and with 1 RVAC down, that timeline stretched slightly longer to make up the lost thrust. Healthy chamber pressure held on all 5 working engines the entire way. The ship was flying a planned suborbital trajectory, not a full orbit, and it stayed locked onto that path the whole climb. The fact that a partial engine failure barely dented the mission profile is exactly the kind of resilience that makes the rest of the industry nervous. The Pez dispenser and Starlink Vine 3. Then the side door opened. Starship deployed its payload through what the team affectionately calls the Pez dispenser, a long slot in the side of the vehicle that pushes satellites out one after another. This flight carried 20 Starlink simulator satellites plus 2 specially modified units packed with version 3 technology, including new solar arrays. The deployment came out noticeably faster than on previous flights, almost turbocharged, and that speed matters more than it looks. Version 3, Starship is built to carry up to 60 of Starlink's advanced V3 satellites, each one designed to deliver 60 terabits per second of downlink capacity. To put that in perspective, that's roughly 20 times what a single Falcon 9 mission provides today. Being able to eject 60 satellites quickly and cleanly is the difference between a clever demo and a real operational deployment system. And the door cycling open, dispensing, and closing on an empty bay is what proved the concept. The Free Flyer camera. This is the part that genuinely shocked people. Among the satellites were 2 modified units the team nicknamed Dodger Dogs, each carrying cameras and flashlights pointed back at the rocket. After deployment, one of them performed what amounts to a free-flying inspection, drifting away from Starship, switching on its lights, and photographing the vehicle's heat shield from outside in open space. The footage didn't come down live. Instead, each satellite recorded the imagery, linked up to the existing Starlink constellation overhead, and relayed the video back back to the ground through the network itself. Think about what that means. A rocket that can launch a camera off its own body, have it photograph the most critical and least understood part of the vehicle, and beam those pictures home through a satellite mesh. The shots of Starship lit up against the black of space, flashlights glinting off the tiles, weren't just spectacular. They were a brand new way to gather re-entry data that didn't exist before this flight. Spicy re-entry and the tile experiment. Re-entry is where starships have died before, and the team openly expected this one to be spicy. This is the most demanding stretch of the entire flight. The vehicle has to scrub off every bit of the enormous energy it gained on the way up, and it does that by slamming into the atmosphere and turning that speed into heat. The ship carried experimental tile configurations, and seeing the tiles still intact on the flaps deep into descent was a genuine win because tile survival was one of the flight's core experiments. Cameras mounted in the flaps and scattered across the hull watched how everything held up, with more sensors buried inside the vehicle itself. Remarkably, even while wrapped in plasma, the ship kept transmitting that video down through Starlink, punching signal through the ionized sheath that normally blacks out communications. Then came the news nobody took for granted. The ship had passed through peak heating and external temperatures were dropping. After all the warnings about a violent re-entry, surviving the worst of it was the moment the room exhaled. Flip, landing burn, and splashdown. The ship wasn't done being tested. Coming down into daylight over the Indian Ocean, the team lined up a series of aggressive maneuvers specifically designed to stress the flaps as hard as possible. Blue ocean and sunlight appeared just beyond the flap as the vehicle dropped toward the water. Dynamic pressure bled off, and then the call came. Landing burn startup. 2 engines lit, the ship executed its dramatic flip from belly down to vertical, and it settled into the landing sequence over the Indian Ocean. Those were the same sea-level engines that skipped an earlier in-space relight. The team had passed on that relight given everything seen on the way up, but kept the engines healthy and ready exactly for this moment. A successful flip, engines firing, the vehicle controlled all the way down. For a flight that loaded this many experiments onto a single mission, watching it stick the hardest maneuvers at the very end is why the industry is still talking about it. Flight 12 packed a full launch, an engine-out ascent, a complete satellite deployment, a self-photographing free flyer, and a punishing re-entry into one mission, and came out the other side with the data to push the program forward. If this is what a single test flight looks like now, the next one is going to be something to see. Subscribe and stick around, because the road to a fully reusable Starship is just getting started.